So question A wants us to show that the probability distribution for X is legitimate. And there are two criteria that have to be met. So the first thing that we need to check is that all of our probabilities are between 0 and 1, which they are. So all probabilities are between 0 and 1. And the second thing that you should have checked was that the sum of all of the probabilities is equal to 1. So if we take each of the probabilities for each one of those outcomes, from 0 to 10, and add them up, you should have gotten a total of 1. So we'll just state that, and they add up to 1. So as long as those two criteria are met, then we know that this is a legitimate probability distribution. So therefore, this is a legitimate probability distribution. Okay. In part B, you needed to make a histogram, and then we were going to use that histogram to describe the distribution. So for the sake of time, I went ahead and sketched the histogram for us. Yours may not look exactly like mine. If you used a different scale, that's okay. But overall, it should have this general shape. You do need to make sure that each of the bars has equal width and that your scale is consistent. So if you did a scale of 2 instead of 1 for every 10th, that's okay, as long as you did that consistently. I used a scale of 3 units on the graph was equal to a probability of 0.1. So we want to address several things. First thing that we notice is the shape of this graph. We've got a tail here to the left, so the graph is skewed to the left. We have one peak, so it is also unimodal. Now, the fact that this graph is skewed to the left tells us a good bit of information about what we're modeling. What we're saying is that it's far more likely that a randomly selected baby is going to fall here on the right side because that's where our peak is. That's where the bulk of our data is. So in this case, since we're talking about APGAR scores, we're saying that a baby is more likely to have an APGAR score on the higher end, meaning that they are probably more likely to be fairly healthy at birth. So a randomly selected newborn most likely have an APGAR score on the high end of the scale. Which means the baby will be fairly healthy at birth. So that kind of addresses not only what the shape is, but kind of what that tells us about the scenario. If we look back at the probability distribution, specifically at the table, we can tell that the median is going to fall somewhere with an fall somewhere in the range of an APGAR score of 8. And we know that because the median is our 50% mark. So if we go back and we add up the probabilities, we will see that we'll hit that 50% mark once we get to an APGAR score of 8. So we'll use that median as our measure of center. So from the probability distribution, we see the median is 8. We can talk about the spread. Now, we don't really know what the standard deviation is, but we can talk about the spread in terms of the range. We know that the APGAR scores vary from 0 to 10, but we can also be a little bit more specific and narrow it in. Not only do the scores vary from 0 to 10, but really anything less than a 4 is a pretty small probability. Okay. So the scores vary from 0 to 10. That's our range. But more specifically, most newborns are going to receive a score between 4 and 10. We could discuss the possibility of outliers, but at this point, it's fairly hard to tell what is and what isn't an outlier. We don't have any obvious gaps or anything like that in our distribution. So it's hard to say that there's anything that falls so far out of the range that we would consider it an outlier without a little bit more information. So at this point, we'll leave the outlier part out because that's not really something that we can determine based on this information. And finally, part C says that we're looking for the probability of getting a APGAR score of 7 or higher. So to answer part C, we're looking for the probability that X is going to be a 7 or higher, so greater than or equal to 7. And we can calculate that probability by adding the probabilities of each of the outcomes that satisfy that. So an outcome of 7 would be considered 7 or higher. An outcome of 8 would also satisfy the condition. An outcome of 9 would satisfy the condition. And an outcome of 10 would satisfy the condition. So we saw that the probability of getting a 7 from our table is 0.099. The probability of getting an APGAR score of 8 is 0.319. The probability of getting an APGAR score of 9 is 0.437. And the probability of getting an APGAR score of 10 is 0.053. So if we add all of those probabilities together, we get 0.908. So if we translate that, the probability of randomly choosing a healthy baby is 90.8%. In other words, 90.8% of the babies measured would be classified as being healthy, as having an APGAR score of 7 or higher.